What is the big deal with AI and machine learning for oil and gas? Welcome to the future of oil and gas pre-drill analytics and management utilizing AI and ML, brought to you by a Texas-based company, PINN AI, LLC. I'm here to introduce you to groundbreaking 21st century methods to utilize state-of-the-art technologies and algorithms to accurately streamline and accelerate the evaluation of all subsurface data types simultaneously. Let's dive in and explore what makes PINN AI a game-changer in the industry. Data integration employing traditional methods. Manual interpretation. Geologists and engineers manually interpret well logs, seismic data, geologic data, completion data, and production data, among others, individually. Independent analyses. Different types of data, as mentioned above, are often analyzed independently and then combined qualitatively. Empirical models, information acquired by observation or experimentation. These models, though improved using current analytical software, use empirical models based on historical data and established geological principles to predict reservoir properties and well performance, remain the standard. Simulation software. Reservoir simulation software is used to integrate various data types and run simulations to predict reservoir behavior. These methods still rely on mathematically calibrated systems without really combining the data types for analysis. Limitations. Traditional methods. Subjectivity. Manual interpretation can introduce subjectivity and bias. Complexity. Integrating multiple data sources manually is complex and time-consuming. We estimate that each well, fully evaluated using various data types qualitatively, may take an experienced geologist and/or engineer for hours per well. Scalability. Hard to scale manual analysis for large datasets and extensive fields. Imagine analyzing 500 wells manually, that's 2,000 man-hours. In reality, what occurs is that far fewer wells are evaluated due to real-life budget and time constraints. There is a better way. Accuracy. Empirical models may not capture complex relationships and interactions between different data types. Data integration with machine learning methods. Automated data processing. ML models can automatically ingest colossal amounts of data, process and integrate multiple data sources, such as well logs, seismic data, production data, completion data, geological data, and more for hundreds or thousands of wells, simultaneously. Feature engineering. ML models can combine features from different data sources to create new variables that capture complex relationships. This is one of the most important elements of AI and machine learning. Pattern recognition. ML models can detect patterns and correlations across different data types that may not be apparent through manual interpretation. Predictive modeling. ML algorithms can predict reservoir properties with much greater accuracy, including well performance, economics, decline curves, a wide range of individual variables important to geologists and engineers. Optimal drilling locations. For horizontal wells, the optimal landing depth in your zone of interest, and a recommended frac recipe by learning from large datasets. Artificial intelligence and machine learning advantages. Consistency. Automated processes reduce subjectivity and bias and ensure consistent analysis. Complexity handling. ML models can handle complex relationships and interactions between different data types. Scalability. ML methods can scale to analyze large datasets efficiently. Accuracy. ML models can achieve higher accuracy by leveraging vast amounts of data and advanced algorithms. Let's take a look at an example comparative analysis of historical versus artificial intelligence and machine learning methods. Predicting reservoir properties. Traditional approach. Well log analysis. Geologists and engineers manually interpret well logs to identify hydrocarbon-bearing zones. Some analyses have been simplified with software packages available to the industry. Seismic data interpretation. Seismic data, if available, is analyzed independently to map subsurface structures. Empirical models. Empirical relationships between well logs and reservoir properties are used to predict porosity, permeability, etc. Combining results. Results from different analyses are combined qualitatively to make drilling decisions. Machine learning approach. Data ingestion. Well logs, seismic data, and production data, among other types mentioned previously, are ingested into the ML model. Data sets including all associated data types are loaded from the outset, from 10 to 100,000 wells at a time. Feature engineering, ML models create new features by combining information from different data types. Training the model is trained on historical data to learn the relationships between input features and reservoir properties. Predictions, the trained model predicts reservoir properties across the field, integrating insights from all data sources. Visualization, outputs are visualized in 3D models and heat maps, showing gradients of porosity, permeability, etc. across the area selected by the client. These advantages, and more, are designed to provide geologists and engineers with more advanced tools that provide greater visibility into the subsurface environment of interest. We've designed our tools specifically for technically inclined oil and gas industry participants to enhance productivity, not replace technical staff. The artificial intelligence and machine learning solutions outlined above are the keys to a quantum leap in acquiring vital information using state-of-the-art oil and gas analytical methods that provide greater accuracy by combining data types. Informed decision-making can occur at an exponentially higher rate and accuracy than historical methods. Utilizing AI or ML methods, providing our clients with a competitive advantage over other operators and delivering streamlined pathways to informed capital deployment, drilling decisions, and field actions. Most importantly, our mission is to put the right data metrics and information into the hands of all sized operators to enable informed investment decision-making and increased drilling success and a measurable rise in profitability. Dallas, Texas-based PINN AI has designed AI or ML-based platforms to revolutionize the way subsurface pre-drilling analyses are accomplished. We are oil and gas professionals with executive-level experience for more than 2 decades. AI or ML for oil and gas professionals, from oil and gas professionals. We've sat in your seat, we know the pressures you face and the load you carry every day, and we've designed the tools we would have wanted when we were leading operations and drilling new wells or acquiring new properties. Get in touch with us today and find out how PINN AI is revolutionizing the oil and gas industry with state-of-the-art tools previously unavailable to the public. Thank you for viewing this brief tutorial.